Welcome back to Differential Geometry. Today we'll be talking about Frenet frame fields in R3. So in this section we'll be using unit speed reparameterizations of all curves. So we're going to start with a definition. So let beta be a function from I to R3. Let that be a unit speed curve. In other words, this is just saying beta prime of s is equal to 0. The norm of it, of course, for each s and I. Okay. Then t equals beta prime is called the unit tangent vector field on beta. Okay, so this is going to be a quick picture based on what exactly this means. So drawing R3, freehanding it, we have some unit speed curve. This is beta. And the tangent vector is going to look something like this, just pointing out. I'm just going to note that t. Okay, so that's our graph for now. Okay, so because t is unit length, we know that t dot t is equal to 0. Because okay, so differentiation of this of t dot t gives you the following. Of t dot t gives, okay, it gives this 2 times t prime dotted with t is equal to 0. And what this tells us is that t prime is always orthogonal to t. And so what is t prime? We can describe it as the turning of beta. So in particular, I'm going to move on to the next definition. The real valued function kappa is such that kappa of s is equal to is equal to the absolute value of t prime of s. For all s and I is called the curvature function of beta. Okay. Well, what do we know about kappa now? Well, because kappa is defined as a norm, we know kappa is greater than or equal to 0 for all s. And we're going to impose a further restriction that this is a strict inequality. So in other words, we're going to say we want kappa greater than 0. So we just can't have kappa equals 0. Okay, moving on to the next definition. The unit vector field n equals t prime over kappa on beta sorry on beta it's called the principal normal vector field is called the principal normal vector field of beta. Okay, so what does this look like? Going back to this picture, the n is going to point inwards like this, and it's going to be orthogonal to t, so we're going to draw it like this. So this is n. So this is our picture right now. Okay, so, and we have one last thing to define. Okay, so the vector field B equals n cross t of beta. I'll make that more distinctive, of the curve beta, is called the binormal vector field of beta. Field of beta. Okay. So, what does this look like? Going back to this picture one last time. So the binormal vector field would look like this. And this is just going to be B. So these, B will be orthogonal to both T and N, and they will all be unit length. So this is our final picture. So we actually haven't proven that B, N, and T are all unit length, but that is what we're going to do next. So, lemma. So let beta be unit speed curve in R3 with positive curvature. Then the three vector fields, the fields T and B on beta are the unit vector fields that are mutually orthogonal. Okay. E and G length and mutually orthogonal. And that's at each point. Okay, so we call this TNB. They constitute the Frenet frame field. On beta, of course. Okay, so for the proof, well, okay, so by definition, the absolute value, the norm of t is equal to 1, and also, since the absolute value of n, the norm of n is equal to the norm of t prime over the norm of kappa, which is equal to the norm of t prime over the norm of t prime. And we're assuming that kappa is greater than 0, of course, so this is equal to 1. Okay, so n is also unit length. And finally, we're going to show that B is unit length. How do we do that? Well, we know that norm of B is equal to norm of n cross T, which is equal to norm n, norm T, norm sine theta, well, the norm of n is 1, the norm of T is also 1, which we just showed those, and the angle between them is pi over 2, and then sine pi over 2 is also 1. So we just got 1, which is what we wanted. Okay, so are they all orthogonal though? Well, we know that B is equal to n cross T, which, just using properties of the cross product, well, this tells you that B is orthogonal to both n and T. So B T. There we go. Okay. So that finishes this proof. And so in summary, B, T, and N are all mutually orthogonal and unit length, and they constitute a frame field in R3, and which we call the Frenet frame field. So I'm going to end the presentation here. Thank you for listening.